In this video, we are going to cover the last concept in chapter 11, which has to do with aromatic compounds. The definition of an aromatic compound is going to be molecules that contain a benzene ring. As you can see, the structures of benzene rings are in the bottom of the slide, and benzene rings are written as hexagons, where there's 1, 2, 3, 4, 5, 6 carbons with alternating double bond, single bond, double bond, single bond, double bond, single bonds. And as you can see, there are two different arrangements for those double bonds and single bonds. Then alternatively, if you don't want to be writing the alternating and double bonds and single bonds, you can also write the hexagon. And then you're going to put a circle in the middle, okay? The hydrogens in the expanded form, or if you don't write them down, is both okay. Now, understand that aromatic compounds, because they have this benzene ring, they are going to have a flat ring structure, again, coming from the benzene ring. And anytime we have an aromatic compound, this benzene ring is going to be present. Another way in which we are naming aromatic compounds is going to be an arene. Now, when it comes to naming aromatic compounds, understand that the first thing that you guys have to learn is the common names that are present for some specific motifs that are part of an aromatic compound, or a certain substituent that is part of an aromatic compound. So when we have a methyl group attached to a benzene ring, that is known as toluene. When we have an amino group attached to a benzene ring, that is known as aniline. And when we have a hydroxyl group bonded to a benzene ring, that is known as phenol. When we have these different motifs in the molecule, we're going to see how that determines the way that we number the carbon atoms inside the benzene ring. In general, when we're naming aromatic compounds, understand that if we have a single substituent in an aromatic compound, we are going to write. So let me just write those. So if we have one substituent attached to that benzene ring, we're just going to write the name of the substituent followed by the word benzene. Because in essence, in aromatic compounds, benzene is going to be our longest carbon chain. Now, as you can see, we have examples in which we have two substituents present in the molecule. When we have two or more substituents present in the molecule, we must designate the positions of these substituents. As you can see, in the following molecules, each of them, in the second, third, and fourth molecule, we have two substituents that are the same. So we have two chlorine substituents. That's where we get the prefix di, and then the name of the substituent, chloro. Now, when it comes to this, remember that in substituents, we learned previously in other functional groups that we have to give them the lowest number. So here, one substituent is going to be number 1, and then the other one, we have to number the ring clockwise or counterclockwise to give the second substituent the lowest number. So for example, in the first two molecules, we are numbering the rings clockwise. where we already have labeled in the second molecule carbon 1 and carbon 2. Then we have 3, 4, 5, and 6. Similarly, in the third molecule, when we're numbering the carbon atoms inside the ring, we have 1 chlorine on number 1, then we have 2, 3, 4. Let me renumber these. We have 1, 2, 3, 4, 5, and 6. Lastly, as you can see, we can number the carbon atoms in the last molecule, on the fourth one, counterclockwise. 1, 2, 3, 4, 5, and 6. Because at the end of the day, the priorities is to give them the lowest arrangement of numbering, not necessarily they have to be clockwise or counterclockwise. Another thing that I want to state is that if we have a benzene ring, understand that this position is not always carbon number 1. And we're going to see that in the examples that we have present in the slides. So let's say, for example, that now these aromatic compounds are going to contain one of these special names, these common names that say that there's a specific substituent in it. Remember, for toluene is where we have a benzene ring with a CH3 group. A phenol is a benzene ring with an hydroxyl group, and aniline is going to be a benzene ring with an amino group. Amino groups are NH2. Okay? Then, in that case, the carbon that is holding that special substituent is going to be carbon 1. So as you can see in the first example, the NH2, that's where we're going to place number 1. These examples illustrate that carbon 1 is on the top of that hexagon, but understand that that is not always the case. It's very important to note that in the examples in this slide, the most important thing to remember is that carbon 1 is going to contain that special substituent that gives the longest carbon chain. So in essence, if I circle the longest motif in this molecule, is going to be that NH2 attached to the benzene ring. And as you can see here, we're going to be numbering this clockwise. 1, 2, 3, 4, 5, and 6. So the name of this molecule is 3-bromoaniline. In the second molecule, as you can see, carbon 1 is holding the OH. We have to number the molecule counterclockwise to give the other substituents the lowest number. So we have 1, 2, 3, 4, 5, 6. And remember, if we have multiple substituents, like in the second molecule, we're going to put them in alphabetical order. So the correct name is 4-bromo-2-chlorophenol. In the last molecule, as you can see, we are going to be numbering the carbons inside the benzene ring clockwise. So we have carbon 1, carbon 2, 3, 4, 5, and 6. And remember, when we are alphabetizing, because we have substituents, the prefixes like di, tri, or tetra do not get alphabetized, and that is why we have bromo before chloro. The reason why we're doing that is because of the B in the bromo versus the C in the chloro. Let's do several examples from the worksheets in order to go from structure to name and also from name to structure. So, as you can see, the first molecule, we have a benzene ring attached to a CH3. There's two ways that we can name it. We can say that this is methyl benzene, and the other name that it has, which is the common name that it is accepted by the IUPAC system, is going to be toluene. The second molecule on the first row, we have two substituents. As you can see, these two substituents, the Br is going to be a bromo group. The second substituent is going to be a chloro group. When we have two substituents in a ring, we're going to give the first, we're going to number the first carbon with the substituent that is going to be alphabetically first, similar to what we did with the cyclic alkanes. So here, I'm going to change my ink to red. This is going to be carbon 1, carbon 2, carbon 3, 4, 5, and 6. So when we write the name of this molecule, remember that our longest carbon chain is going to be benzene. And on carbon 1, we're going to have a bromo group. On carbon 3, we're going to have a chloro group. And then the last word is benzene. Now, as you can see, on the first molecule in the bottom row, we're going to have an ethyl group and a fluoro group. Because we're dealing with only two substituents, when we are numbering the carbons inside the benzene ring, the one that comes alphabetically first is the one that is going to receive the lower number. So this is going to be carbon 1, 2, 3, 4, 5, and 6. Remember, in aromatic compounds, the last word can be benzene. And in this case, we're going to have on carbon number 1 an ethyl group. And on carbon number 4, we're going to have a fluoro group. Remember, all of this is one word. Number and letters, we always are going to separate them by a dash. Now, in the last molecule, understand that here we are going to have the benzene ring as our longest carbon chain, or this is one of the occasions in which we have one of those special substituents that we can incorporate into that benzene ring and say that that is going to be our longest carbon chain. So remember that an amino group or NH2 group, when it is present in the benzene ring, that whole thing is known as an aniline. Okay? And then when it comes to that, because the NH2 is what gives the name of the longest carbon chain, the carbon that is holding that amino group is going to be carbon 1. Then we're going to number the carbons in the benzene ring in clockwise or counterclockwise to give the substituents the lowest number. So if the carbon holding the amino group is number 1 in this molecule, we need to go clockwise. So as we go clockwise, that's carbon number 2, that's carbon number 3, carbon number 4, carbon number 5, carbon number 6. So our longest carbon chain is going to be that aniline motif. And then in this molecule, we have two substituents that are the same. So on carbon 3 in the benzene ring and carbon 4, we have 2 chlorines. So we're going to say this is dichloro. And the last word is aniline. Now, what if you're given the name of these compounds and you need to draw the skeletal formula for them? We tend to write skeletal formulas for aromatic compounds because when it comes to the benzene ring, it's easier just to write the hexagon in the circle or the alternating double bonds and single bonds. Let's do all 4 examples for part M in our worksheet. So the first compound that we have is nitrobenzene. So remember, these are all aromatic compounds. So when it comes to nitrobenzene, the first thing that we're going to draw is our benzene ring, which is that hexagon that has a circle. And if it's nitro, that nitro group is an NO2 substituent, which it cannot be confused with an NH2. So NH2 is amino, NO2 is nitro. So I'm just going to write a note here in the corner. NH2 is called an amino group, while a nitro is an NO2 group. And then here you can place that NO2 group wherever you desired in the ring. I'm just going to place it in this corner because since they're one substituent, it doesn't matter where we place it in the benzene ring. So when we look at molecule 2, we are going to have a tribromobenzene. So for this molecule, we're going to redraw our hexagon. And in this case, I'm choosing to write the alternating double bonds and single bonds. So there's a double bond, single bond, double bond, single bond, double bond. Then we are going to place 3 different bromines. So if I select that this is carbon 1, this is 2, 3, 4, 5, and 6, then I'm going to be drawing bromines again at the positions that my name says. On carbon 1, there's a Br. On carbon 3, there's a Br. And on carbon 5, there's a Br. And that's the structure for 1,3,5 tribromobenzene. On the molecule on Roman numeral 3, we have 4-ethyltoluene. Toluene is a benzene ring that is attached to a CH3. And the carbon atom that is holding the CH3 in the ring, that's going to be carbon 1. Then we can go clockwise or counterclockwise. In this case, I'm going to number counterclockwise. So this is carbon 1, this is 2, 3, 4, 5, and 6. And on carbon 4, I'm going to draw an ethyl group, which is known as a CH2, CH3 group. Now, as you can see, those 2 substituents, the CH3 and the CH2, CH3, I wrote out the carbon and the hydrogens. I can redraw this. So this squiggly line is going to be illustrating the redraw. I can illustrate this as just a line, and then the ethyl group is going to be this. Because as you may remember, when you learn how to draw alkanes, that's how you draw the skeletal structure for methyls and ethyl groups. Let's do the last molecule, which is 3-chloroaniline. So again, in 3-chloroaniline, let's say that I decide to draw my benzene ring. Again, double bond, single bond, double bond, single bond, double bond. And aniline is going to contain an amino group. So inside this benzene ring, we are going to be drawing at a position an NH2 group. So this NH2 group, the carbon that is holding the NH2 group is going to be carbon 1. Then we are going to number the ring 2, 3, 4, 5, 6. And on position 3, I'm going to write a bond to a chlorine. And that is the structure of 3-chloroaniline.